Hello to everyone. This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. The subject is matrices and calculus. Today, we are going to discuss the topic on the definition and terminology, Module 3, that is related to the mean value theorems under here, the Jacobian transformations, functionally dependent and independent variables. This is under the Module 3. In previous lectures, we discussed clearly regarding this one, the Module 3, the question bank discussion is over. And again, that individually, the topic wise, everything it is covered in the previous lectures. But today, only the definition and terminology, that means whatever the definitions are occur in this Module 3, that we are going to discuss that today class. First of all, we need to discuss what is the syllabus of this the Module 3. And again, after that, one by one, we need to discuss the definitions, whatever it is occur. Here actually, the Module 3, it is based upon the functions of single and several variable. Under the topics are covered like here, the mean value theorem and also the functions of several variable. The mean value theorem under here, the concepts are there here involving one is a Rolle's theorem, the second one is a Lagrange's theorem, and the third one is a Cauchy's mean value theorem. Here the proofs are not required based upon the statements, and again based upon the statement like the problems are it is required. This is the as per our syllabus. And again the part B, whereas in the functions of the several variable, and again here that is a partial differentiation, and based upon the partial differential equations, that is a Jacobian transformations, and again the functionally dependent and independent maxima and minima. And again under the two variables and also like the three variables, and finally it is a Lagrange's multipliers. These are the under the Module 3, we need to discuss the definition point of view. First of all, what is a define the continuous functions? That means in this party, that is a mean value theorem, we need to aware of the continuous and again the differentiable and again the limit exists. These are the three conditions are required, and based upon that it is required to understand what is a Rolle's statement, again the Lagrange statement, again the Cauchy's mean value theorem, and again the geometrically also how to define the described regarding all these conditions. Here the discontinuous functions. As we know that generally the function is a limit is exist, and again moreover the function is at x is equal to like that particularly f of x is equal, that is a limit x is equal to a, that is a f of a, that is a function is said to be continuous function. That in other terminology, the limit is exist is nothing but the LHS limit and again the RHS limit both are the same, then only the function is said to be the limit exists. In case the limit is like LHS limit and RHS limit, that means the left hand side limit and again the right hand limit side is the particular value, the values are not equal to, the function is said to be not a continuous. That means it is a does not exist the condition. And based upon the conditions here the definition of the continuous is nothing but a function f is continuous at a point x is equal to a. Here the three conditions are required to satisfy. One is the function is defined the interval the given particular a value. That is nothing but the function is said to be continuous. One is the function is defined at the point x is equal to a, and again the second one, the limit of f as x approaches to the from the right hand side and again the left hand side exists and also equal. That is the meaning of the LHS limit and RHS limit, both are the limits are existed. That is the same, the condition is satisfied. And the third condition, the limit of f as x approaches to a is equal to, that is a f of a. That means according to x is equal to limit as x is equal to a, f of x is equal, that is a f of a is a condition. That means together these are the three conditions are satisfied, then only the function is said to be continuous function. Second one, the state the critical point and also the nature of the functions. And again, when we are going to say something, the function is a critical point to find the value, means whatever the given function, we need to derive it with respect to x, then you obtain the values. The values is called as a, that is a critical point. And based upon this one, here according to that is a critical point or something like according to that is with respect to x and also y, you need to find the solutions. That is nothing but the function is x square minus 2x plus 2y square minus plus 4y minus 2 is equal to 0. And based upon that, we need to find out what is a f dash of x is equal to 0 and also f dash of y is equal to 0. And based upon the two equations solving, we get the some two equations. By solving the two equations here, you obtain the values are that is 1 comma minus 1 is the value. This is the meaning of the critical point only, the conditions. Like indirectly it is a stationary point like that. And next one, the state the differentiable function. The differentiable function is nothing but the function is a limit is a exist indirectly, it is a condition, that is a derivative is a existed. That means a function f of x is a differentiable at a point when there is a define the derivative. That means same like it is also the continuous function, but it is a derivative exist is nothing but whatever the function is there, you need to find the derivative. At the derivative, it is exist is a condition satisfied. And again, this means the slope of the tangent line of the points from the LHS is approaches to the same value of the slope that is a tangent of the right side. That means same like the continuous function without applying any the derivative, the LHS limit and RHS limit both are the same. But whereas in the tangent like is nothing but it is also derivative. That means whatever the function is given, and after finding the derivative, you need to replace that particular value at LHS limit and RHS limit. Both the limits are same. The function is said to be that is a tangent derivative is existed. That is nothing but it is a differentiable functions. And next coming to point based upon the derivative and also continuous function. And before going to understand, we need to what is a like a Rolle's theorem, and again what is the geometrical application of the Rolle's theorem. And again here, before going to discuss here the Rolle's theorem, we need to aware of the like intervals like based upon the what is the meaning of the like this one and what is the meaning of this one, what is the meaning of this one, and again what is the meaning of this one condition. That means we need to aware of all these the intervals. And again where we are observing this one, this it is called as open interval. The open interval is nothing but for example 1 comma 5 is the condition. For example, that 1 comma 5 is nothing but open is nothing but according to the meaning of it is a not including that 1 comma 5. That means the inside of the point it is a 2 comma 3 comma 4 comma it is a 5. That is a open interval. And again similarly 1 comma 5. The meaning of it is called as a closed interval. The closed interval is nothing but not only the 2, 3, 4 and also 5. It is not including it is a 5. That is 2, 3, 4 only. And again that is open interval. And whereas in the closed interval, it is not only the 2, 3, 4, including the last one and again the inside that is a first one. That means including that first and also that is a last one. And again including the first and last, and in between the vowels are also that is nothing but it is a closed interval. And again next one, these are nothing but it is a half intervals. And again half interval is nothing but one side it is open, other side it is a closed. For example here also, for example 1 comma 5. That means based upon that one is a open interval, it is not including like the 2 comma 3 comma 4, and again here it is a 5 is a closed. That means including the 5 is also the value. This is the 5 value. And again next to similarly 1 comma 5. That means including like not only 2 comma 3 comma 4, and again here 1 is also closed. That means 1 is also including the value. These are the meaning of, we need to understand what is the meaning of the open interval, what is the meaning of the closed interval, and what is the meaning of the half intervals. And based upon that, we need to discuss according to the Rolle's theorem. And again here, when it is satisfied the Rolle's theorem, that we need to understand and according to statement conditions. Here actually generally the Rolle's theorem is applicable, the three conditions are required to satisfied. And again what are the three conditions? Here that is nothing but f is any function, that is f is a function such that it is first is a continuous function in the closed interval, that is a comma b. That means according to previously clearly explained what is a closed interval, and based upon that the function is like discussed already, that is a continuous function. Based upon the continuous statement and based upon the closed interval, the function is satisfied the continuous function in the closed interval a comma b is a conditions. And second one, the function is a derivable. That means it is a differentiable. And according to the meaning of the differentiable, after given the equation, we need to apply the derivative. We need to replace it to open interval a comma b. According to by the definition, it is inside of the values are satisfied, therefore it is a function is a differentiable. That means f is a continuous in the closed interval a comma b, the differentiable in the open interval a comma b. Not only these two conditions, and including that f of a is equal to f of b also. That means whatever the function, we need to replace that first point and also the second point, that f of a is equal to f of b is also satisfied. Then there exists two. If the three conditions are satisfied, then there exists at least one point such that is a f dash of c is equal to 0. That means these are the three conditions are required to satisfied. One is a continuous function in the closed interval, and second one is a differentiable in the open interval, and the third condition is f of a is equal to f of b. If the three conditions are satisfied, further we need to proceeding. Then there exists at least one point c belongs to a comma b such that f dash of c is equal to 0. These are the conditions are required to satisfied for Rolle's theorem. One is a continuous closed interval, and differentiable open interval, and again f of a is equal to f of b. Then there exists c belongs to a comma b such that f dash of c is equal to, that is the 0 conditions. And further, what is the geometrical application in the Rolle's theorem? This is also like according to the definition point of view, the geometrical applications in the Rolle's theorem. And based upon the statement of the Rolle's theorem, the geometrically how to define the Rolle's theorem. Like that, according to f is a function a to b, a comma b to r is a function satisfied the three conditions of the Rolle's theorem. Then the graphically, that is a graph of the we need to explain that is geometrical limits, that is a graph of the function. For example, while we are going to draw that according to this the graph, while we are going to observe here. Clearly it is satisfied. Here fi is a continuous function, means it is a without any break. That means according to, for example, we are going to take the curve, it is without any gap. That means without any break, that is a continuous. And again it is also, for example, other curve, it is also without any gap, that is a without any break, it is a continuous function. And again next one, if the function is a differentiable, that means the derivative, it is a tangent is also, it is satisfied according to the tangent at the point. It is also unique tangent at every point x is equal to c. And again where a is less than, that is a b is the conditions. C is the tangent at lies in between, that is c between a comma b. And again the third condition, f of a is equal to f of b at the end points a comma b are equal. That means according to here, that a is nothing but it is a, that is a means it is f of a, and here f of b, that is both are the equal. That means according to based upon these are the three conditions. One is a continuous, and second one is a differentiable, and again the third condition, f of a is equal to f of b is satisfied. Therefore, based upon this one, the Rolle's theorem at least c belongs to a comma b such that f dash of c is equal to 0 is satisfied the condition. These are the geometrical approach we can define that is the Rolle's statement. And further here, that is a Lagrange's theorem. The Lagrange's theorem is also nothing but same like that according to the Rolle's theorem little bit part. One is a function, that is f of x be a function such that is a f is a continuous function in the closed interval a comma b. And the second condition, it is as per the definition of the continuous we need to understand, and closed interval a comma b is the meaning. And second one, that f is a differentiable function and in the open interval a comma b. But here these are the two conditions are sufficient, and based upon that, then there exists c belongs to a comma b such that f dash of c is equal to f of b minus f of a by b minus a is a condition. These are the three conditions we need to repeat. That means first and second condition is essential, and based upon that we need to find the solutions. And in this part, f of a is not equal to like that f of b, it is not doesn't matter. Depend upon the equations we can find out, that is f dash of c is equal to f of b minus f of a by, that is b minus a is the condition. Then there exists c belongs to a comma b is the conditions. And these are the Lagrange's theorem. Under these are the definition point of it, is two conditions are required. One is a closed interval, it is a comma b, and again the differentiable in the open interval a comma b. Then there exists c belongs to a comma b such that f dash of c is equal to f of b minus f of a by b minus a is the condition. And further, we need to discuss same like that previous one, that is a geometrical application of that is a Lagrange's mean value theorem. The geometrical application is nothing but here also we need to draw the curve that is based upon that. While we are going to observe here the draw, that is one is according to here, the condition is according to this continuous function without any break of the conditions. That means clearly the function is a continuous function is satisfied, and the derivative is also existed because of the tangent is also available here. The tangent is also available here, and again that a comma b, it is a continuous function, and again the tangent is also available, and again but here the f of a is not equal to f of b because of it is a is equal to f of a, and again the f of b is nothing but means it is a not equal to same the conditions. That means it is required up to here, but it is above the condition it is satisfied. That means it is clearly showing it is a f of a is not equal to f of b. Then there exists c belongs to a comma b such that that is a f dash of c is equal to f of b minus f of a by b minus a is the conditions. These are the required conditions clearly satisfied. Therefore, this is the statement for the Lagrange's mean value theorem under the geometrically Lagrange's mean value theorem. And further, that is a Cauchy's mean value theorem. And Cauchy's mean value theorem is nothing but it is especially comparison between the first two Rolls and Lagrange's, whereas the Rolls and Lagrange's it is a one function, but whereas the Cauchy's mean value theorem, which is occurring with the two functions. F is a function a comma b to real number any value, and g is a function a comma b to real number any values. And based upon these are the two functions here, but it is two conditions are mandatory. One is a f comma g are the both are the continuous in the closed interval, whereas in the previous two conditions only one function that is a continuous in the closed interval, but in this here f comma g both are the continuous, but it is a function is under the closed interval a comma b. Here it is a f comma g are the two functions. Because of given the two functions, therefore these two functions are satisfied in the continuous function. And similarly f comma g are also the derivative exists, that is a differentiable in the open interval, that is a comma b is a conditions. Same the definition of the previous, that is a differentiable it is existed, but here it is under the open interval a comma b is a condition. And here finally the third condition provided, that is it is important, that is g dash of x is not equal to 0. Because of if it is g dash of x is equal to 0, the output it is not able to get the solution. Therefore, based upon this g dash of x is not equal to 0 for all values of x belongs to a comma b is a condition. Then there exists c belongs to a comma b is a mandatory, but here it is a formula f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a is a conditions. Here it is according to the Rolls and Lagrange's comparison to like that, but it is somewhat it is two functions are there based upon the club into the two parts, then it is able to define that is a Cauchy's mean value theorem. One is here f comma g are the continuous function in the closed interval a comma b, and f comma g are the differentiable in the open interval a comma b, and g dash of x is not equal to 0. Then there exists c belongs to a comma b such that f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a is condition. This is the especially for the Cauchy's mean value theorem under the given the two functions are involved. And these are the main three rules which is occurring in the equations. And these are the particularly up to the Cauchy's mean value theorem is a part here, that is based upon the mean value theorem, that is a definition point of view. Next one, that is part B, that is functions of several variable. That as we know that the several variable is nothing but based upon the more than the single variable. That means it is for example x is the single variable, that is more than the one is nothing but x comma y or something x comma y comma z, and at the time of this one it is called as a functions of several variable under the two variables and also the three variables. And especially it is based upon the several variable which is discussing based upon the particularly the derivatives under the partial derivatives. Because of that partial under the differentiation, one is the ordinary, second one is a partial differential equation, and based upon the ordinary differential equation one dependent and again with respect to one independent variable. But whereas the partial differentiation, that is one dependent but at least two independent variables are the required. And based upon it is discussing here, there is a two independent variable or something, the three independent variable is based upon the partial differential equations. We need to aware of the concept. And based upon the partial derivatives, as you know that one is a p comma q comma r comma s comma t, that is these are the first order, these are the second order conditions. And again here, before going to discuss that, it is a Jacobian function is required. The Jacobian is nothing but it is a scientist name. That is a Jacobian is nothing but it is a scientist name. It is assumed that that is based upon the J is the condition, and J is nothing but the Jacobian. Here the main concept is to based finding the determinant conditions. Here what is the dependent with respect to independent variables. Here if two variables, that is u is a function of x comma y and v is a function of x comma y, are two functions of the independent variables under the x comma y. That means u is a dependent, and again the independent variables are x comma y. This is nothing but u is a function of x comma y and v is a function of x comma y. And with the help of this, it is denoted, that is a Jacobian of u comma v with respect to x comma y, and is denoted by the symbol is j. J is equal to nothing but it is sometimes it is a j only. That is a j is nothing but j of u comma v by x comma y, because of these are the dependent, these are the independent variable. That means by using the partial derivative, that is dou of u comma v by dou of x comma y, and is equal to the determinant condition, that is a u2, that is vx, and u2 vy, and v2 vx and v2 vy is a condition. That means here we need to consider v is a function of x comma y and v is a function of x comma y. That means u2 ux is a ux and u2 vy is a uy and v2x is a vx, and second one is also v2 vy is a conditions. This is nothing but it is called as a Jacobian of u comma v with respect to x comma y under the two variables. And similarly, for example, the three variables, that is a dependent and independent, is nothing but it is nothing but u is a function of x comma y comma z, and v is a function of x comma y comma z, and w is also a function of x comma y comma z. That means here the dependent is nothing but v, and again the u, v, w, and the independent variables are it is u, x, y, x, y, z, and it is also x, y, z. That means u, v, w with respect to x, y, z. And it is denoted by that under that Jacobian, it is also j is equal to simply j of u v w by x by z is equal to that 3 by 3. Because of the 2 is given, that means that is a 2 by 2, whereas the 3 is nothing but it is a 3 by 3. The 3 by 3 is nothing but here also u x y z and v x y z and w x y z. That means u x u y z, v x v y v z, wx wy wz. And based upon this one, we need to obtain that is a 3 by 3 determinant. We need to find the solutions, that is ux uy uz and vx vy vz and wx wy wz. We need to find the value. This is nothing but it is called as a Jacobian of the function. This is also like a definition point of view. What is a Jacobian? How to define the Jacobian under the two variables? It is maybe chances. And again, similarly, it is based upon the three variables are chances. And similarly, any number of variables are also we can define based upon this the concept only. J is the conditions. And next, what are the properties of the Jacobian? The properties of the Jacobian is nothing but one is a function is based upon that. If it is a j is equal to the basically u of x comma y by j of x comma y is equal, and also the j dash is nothing but the reciprocal, that is the reverse of the j, that is a d of j dash is nothing but j of dou of x comma y by dou of u comma v, and based upon the j and j dash we can define j into j dash is equal to the value is a 1 conditions. This is the fundamental property, that is j is equal to j and I is equal to 1. And similarly, if u comma v are functions of x comma y, that means u is a function of r comma s, and again v is also a function of r comma s. That means dou of u comma v by dou of r comma s. And again similarly, r comma s is also a function of, that is x comma y is nothing but xy, and again s is also a function of x comma y. And based upon these conditions, it is one is the dou of u comma v by dou of x comma y, and again second one dou of r comma s by dou of x comma y. That is nothing but if it is considered this one both are the same satisfied, that is nothing but this one. It is a conditions. And if it is a similarly Similarly, if u comma v are functions of x comma y, if it is a u comma v are x comma y is nothing but u is a function of x comma y and v is a function of x comma y. That means according to whenever you are calculating that u comma ux and also uy and vx and also vy, the value of det value. For example, the det is equal to the given the dependent. And as we know that the dependent is nothing but the det of the value is nothing but the det of j is equal, that is a 0. And again, according to the dependent, that linearly dependent or any dependent, that is a det is a 0 value. Therefore, similarly here also the condition is a, the Jacobian is also functionally dependent is nothing but the value is a 0 conditions. That is a nothing but, and similarly u comma v comma w are also functions of, that is a dependent is nothing but the j of, that is equal to 0. But this is the based upon the, that is a 3 by 3. Therefore, the 3 by 3 det is also we get the value is 0. And we need to remember that whenever the function is functionally independent, the independent is nothing but the det value is not equal to 0. That means especially that it is equal to 0, the function is dependent. The function is not equal to 0 is nothing but it is linearly independent of the conditions. These are the, remember the conditions. Yeah. And we need to remember this is also the, what is the implicit function, that is for the Jacobian function. That means under the 2 variables and also 3 variable, that actually the implicit function is nothing but whenever the function is not possible to separate. That means it is not possible to separate the function at the time of we need to applying, that is the implicit function. That is nothing but we need to assume the 3 functions. For example, the given problem is the 3 functions, that is the 3 equations. We need to assume that f1 is a function of u comma v comma w comma x comma y comma z is equal to 0, and second function f2 of x u v w comma x y z is equal to 0, and third one f3 of u v w comma x y z is equal to 0. And based upon that, that is a implicit formula that that is dou of u comma v comma w by dou of x comma y comma z is equal to, similarly, dou of x comma y comma z, whatever it is there, what they are asking to find out, that is depend upon our choice. We need to assume that three variables are like that, 3 functions are, we need to assume that it is a minus 1 whole cube is a formula. That is minus 1 like a whole cube into, that is a under here it is a 2 variables, and it is also dou of x comma y comma by dou of u comma v. That means first one is the 3 variables, and again the second one is 2, and based upon that first one it is a minus 1 whole cube, because of the 3 is existed, that is a 3, and again that 3 variables are nothing but f1 and f2 and also f3. And again here that with the help of this one, the denominator xyz is, we need to assume that numerator of the denominator, and whatever the numerator, that we need to assume that that is the denominator of the functions. And based upon that, right side is also that 3 is nothing but it is also minus 1 whole cube, and again it is also dou of f1 f2 f3, because of it is a 3 is nothing but it is 3, and again it is also 3 is nothing but f1 f2 and also f3. But here the numerator xyz is nothing but that you put in the denominator, and u comma v comma w, the denominator you can put in the numerator of the functions. That we need to observe that. And same here also, that second one, the dou of u comma v by dou of x comma y. That means it is also, it is 2, because of the 2 variables are, it is a 2 functions, that is a minus 1 whole square, and again it is based upon this one. This is nothing but f1 and also f2, and here also that u x comma y is nothing but the denominator in the numerator, and u comma v the numerator in the denominator conditions. And similarly the right side is also, that is a minus 1 whole square, the dou of f1 f2 means it is also the 2 conditions, it is nothing but it is 2 is nothing but it is a whole square, and again that is f1 and also f2, the denominator u comma v that you put in the numerator, and x comma y put in the, that is the denominator is the conditions. Same based upon these conditions, we need to apply any number of variables, even it is given like that 4 by 4 also we need to apply according to this is the conditions. This is applicable only whenever the function is not possible to separate the variables. At that time we need to follow the strictly, that is a implicit formula. We need to apply according to, by using this formula we can get the solutions. Yeah. Next here, what is extreme values and also stationary values, and again the turning values and also saddle point. The extreme values is nothing but whatever the given function, we need to find out the neither the maxima nor minima values. That is called as a extreme values. And stationary values are turning values. The stationary values are turning values is nothing but whatever the given function, we need to find out that is a p comma q is equal to 0 by solving the first order derivative, that is a pq do by do x and do by do y is equal to 0. At the point you get the values by solving that p and q is equal to 0, we get the equation. By solving the two equation, we get the values. That values are called as a stationary values, or sometimes it is called as a turning values. And next value, it is a saddle point. The saddle point is nothing but neither the maximum nor minimum of the given function at particular stationary point. Stationary point. Yeah. And next one, what is the Lagrange's multipliers method? The Lagrange's multipliers method is nothing but whenever the two functions are occur, we need to follow that Lagrange's multipliers method. This is especially to finding the maxima or minima of the values. And again here, the method is applied for the maxima and minima of the given functions, and it is the conditions are like nothing but it is a constant values, that is a lambda connected with any factors. And the drawback of this method is that have the no information about the nature of the function, that is directly. That means it is not possible to finding the no information about the nature of the functions, that is a maximum or minimum. There is a drawback. And again here, whatever that treated as lambda, that is called as Lagrange's multipliers method. And with the help of this one, it is something, the 2 points are given, what is the equation formation, that is with the help of the PQ is nothing but square root of this one. And while based upon this one, that is squaring on both sides, we need to eliminate, that is a under root. Yeah, explain the functions u and v are functionally dependent. That is nothing but dou of u comma v by dou of x comma y is equal to that is a 0 value as per the definition of the functionally dependent. That is Jacobian. Recall the stationary value. Stationary values are obtained with the help of the by solving p and q is equal to 0. That means dou by dou x is equal to 0, and again dou by dou y is equal to 0. By solving these two equations, we get the values. The values are called as stationary values. That is nothing but meaning. And next one, stationary or critical point. The critical point is also nothing but by solving that same value, that f dash of x is equal to 0. That is single way. Like saddle point. Saddle point is nothing but neither maxima nor minima. It is stationary point. It is stationary point. Not minima. That is the meaning of these conditions. State the Euler's theorem on partial derivatives. Actually, this is not related, but we need to keep in our mind that is the Euler's theorem. The Euler's theorem is nothing but dou x into dou by dou x plus y into dou by dou y is equal to n into u. That is nothing but n into x into, that is fx, sorry, dou by. The function is homogeneous functions. That means the degree is the like 0 degree. That is called as a. That is n is nothing but that is a first order derivative. Critical point. Critical point is nothing but same in the first one, that is a f dash of x is equal to 0. By solving that, we get the value of the particular value. The function f of x comma y is equal to 1 plus 2x plus 8y minus x square minus 2y square. H is one critical point. Determine its position of the nature. That is 1 comma 2. Same here also based upon that is the conditions. Like based upon the stationary point. The above the problem like. State the critical points of the function. Same here also we need to find out. So f dash of x, find the value. We need to get the values. State the horizontal tangent to the surface, that is also condition when x is equal to 1. Here also we need to find the same solutions. State equations most closely corresponding to the sketch of the surface below, that is z is equal to 5 into minus conditions. Then based upon the equations, we need to assume the state equation format, and after that we need to find the solutions. It is particularly x is equal to y is equal to 2003, that is a solutions. First order derivative with respect to x, that is nothing but 3 into cos y is a constant, that is a 3 into e power of 3x. Sorry, it is a cos y into, take out common, it is a derivative, that is nothing but 3 into e power 3x into cos y. That is the first derivative. It is nothing but p is a value. That is a first order derivative. And similarly state the first order derivative of the with respect to, that means f5 are asking with respect to y. With respect to y is nothing but x cube is take out common, that is a 2y less 3x common e power y. That is nothing but the problem is obtained. It is nothing but p is a value, small p. They are asking what is the small p. State the second order partial derivatives of f of x comma y. That is r s t. Sorry, r is a t. And other thing is also we need to calculate, that is state the second order. That means we need to find out r comma s comma t. Actually, first of all we need to find out what is a p comma q, and again after that r s and t. That is the meaning of r is nothing but, that is f xx, and s is nothing but f xy, and t is nothing but f y y. And here also second order is nothing but we need to find out p comma q is first, and again after that what is r comma s comma t. That is nothing but f xx and f y y, and that is f xy. F xy and f y. We need calculating that these are the first order and these are the second order partial derivatives. We discussed previously in the last sessions, or also we discussed clearly about that under the module for like 3, at the time of the partial derivatives and maximum minima, we discussed more and more clearly the conditions. Yeah. Now find this maximum, it is the conditions. State the points of the inflections of the pointer in the interval. That is clearly that what is f dash of x is equal to 0. We need to solve the solutions under in between the -2 comma 10 value. State the points of the inflection of the point f of x, and it is also we need to find out, that is x square, like that. It is what is the value of the f dash of x is equal to 0, and based upon this obtain the values. We need to find out what is like under the limits, whatever it is satisfied. Yeah, these are the some of the problems definition point of view. Some problems are also which is occur under this is the module 3, and again and that is nothing but under the module 3 this is the like particularly the several variables, and also the Jacobian, that mean value theorem, and Jacobian like mean value theorem, and also the Jacobian like partial derivative, that is several variables. I hope everybody understood this module 3, that is a definition point of view. Everybody do the hard work. I hope everybody understood. Okay, if any doubts in this particularly the definition and terminology also, give me the reply in the below the link. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.